Thanks a lot, Katrin. Yes, I would first like to point out that this is joint work with my colleagues Florian Fink and Christoph Ringelstetter. Let me start with some motivation. When you look at standard modern repositories in libraries, you will see that all these documents typically come with metadata that describe subjects and topics covered in the text. This is what you could call a deep subject classification, and it's often based on some kind of classification system behind, for example, the universal decimal classification or related systems. In this way, subjects are often used as a primary key for bringing order to document collections, and they of course support users that are interested in particular fields to find the documents they really want. Now, when you compare this situation with OCRed, historical text from the recent digitization tsunami, how I would like to call it here, then you will see that these documents typically come with very poor metadata, and they do not have a subject classification. And this means that there's a missing order on the whole collection, and essentially we only have keyword search to find what we are interested in. And we do not have any kind of survey what a collection is about and what the topics are that can be found in the collection. And this is, of course, not a completely satisfactory situation. So this motivates the question, if we can automatically find subjects and topics covered, it's clear that a manual detection of topics would be too expensive. There are simply too many documents to deal with this job. When we have a closer look at automated topic assignment, the task should be more or less clear. We want to automatically compute all topics and fields that adequately describe the contents of a given document, and these topics should come with a natural hierarchical order. And the challenge, of course, is that there's really a huge number of possible topics and fields with encyclopedic coverage, and we also really need a hierarchical order to get useful results, as here exemplified by the chain from science to mathematics to algebra to group theory to permutation groups. Chains of this are quite typical in all this subject classification stuff. If you compare automated topic assignment with another prominent technique from computational linguistics, document classification, then you see that it's really a much more ambitious and completely distinct task. In document classification, we typically only have a small number of given disjoint fields, such as politics, science, and sports. And the task is just to find the best label or the best labels for a given document. Here the task in automated topic assignment is really much more ambitious. But after all, what we have in mind when we are looking at automated topic assignment is not only just a replacement for manual techniques, but we have also some new visions, and these new visions are by automated techniques, we could not only assign topics to a full document, but we could assign topics to document parts on all levels of granularity, for example, to chapters, to pages, to paragraphs. And this could lead to a kind of horizontal access to documents where we move from one topic found in one document to the same topic found in another document, and where we use topics found in document parts to link these document parts, and across repositories we could use these techniques to detect kinds of topic reuse. Perhaps the e-humanists among you have heard about text reuse. Text reuse considers the problem if long parts of texts occur in several documents in diachronic collections, and here we could deal with topic reuse and look for documents that treat the same kind of topics, when we could find parallelisms and differences across distinct repositories and sub-repositories. It would also be possible and interesting to use these techniques in diachronic corpora to do a kind of timeline and trend analysis and to look on the prominence of certain topics around in several periods of time. The method that we used here in our experiments goes back to a university spin-off that was founded by our group a couple of years ago, which is completely concerned with topic assignment to texts, and the main commercial applications are in the area of headhunting and trend analysis, etc. One word to our background technology. In contrast to most approaches on the market, our techniques are not based on statistical methods, instead, or not primarily based on statistical methods. Instead, we have a huge semantic net in the back. This is one important value of the company. It was developed over many years. And this net has something like 120,000 nodes. Often we call them only topics, but what these nodes stand for are not only topics in the usual sense, but also persons, organizations, events, geographic locations, time periods, etc. And this whole net is ordered as a directed acyclic graph, which means that you have a hierarchical order, but this order is not a tree-based order. So one special subject may have several more general subjects in this graph. The topic names, the node names, come always with many linguistic variants to support applying these nets on real texts. So in the background of this net, we have many linguistic variants, and also a characteristic feature is that we have many multi-word expressions. The main focus so far is German, but we also have an English version, and the English version is the version we used here. All of you can just use or check this technology. There's a free web service available in the web, and in the paper you found in the proceedings you have web addresses where you can find this web service. In this web service, users send in a manual way or per an XML interface texts to the engine, and they receive the topics that were found in the text, and these topics are ranked using 2 relevance scores. And you even do not need to register for using this web service. It's really completely open and free. Just a little example to give you an impression. On the left-hand side, we have a small text recently found in a Wikipedia article, and the result, which is the output of the topic zoom engine currently, is this little table, where you see that this article or this text is about South Africa, about elections, and then you find this hierarchical ordering. The net knows that South Africa is an African country and it belongs to Africa, and elections, it knows that this is a kind of political event and it belongs to the field of politics. And I will not comment on a brief remark to the numbers you see here. The weight is just here trivial. It denotes the number of occurrences of text parts which belong to this topic. Here it's trivial since the text is very small. Each essential text part which we have found only occurs once. In the second column you see the degree of generality, and that indicates how deep the topic is in our hierarchy. There's a particularity, so don't wonder if there are no degrees 1. For some strange reason, degree 2 is the most general degree in this net, which means that politics here is the most general topic. And then what we use is a significance value, and with this significance value, we want to introduce a kind of eye-catching factor of a topic found in a document. And this significance factor takes into account that when we just would count the number of occurrences, then more general topics would, of course, in general, occur more often and get more importance and weight. That's not what we want. We want to find the most specific and characteristic topics. and this is why specific topics get a certain boost, and the resulting value is this significance value you see here. Now, the questions we asked here in this experiment is if this technology can also be used to bring order to collections of OCRed historical texts. And in more detail, we were interested to see how topic assignment is affected by OCR errors. Second, how topic assignment is affected by particularities of historical orthography. And of course, we also wanted to know if this topic zoom hierarchy, which is of course has been designed for modern topics, is suitable for finding topics in historical texts also. For our experiments as a historical corpus, we used the Zedler lexicon. The Zedler lexicon is the largest and most famous 18th century German encyclopedia. It's really huge. And one remark which is important here, if you look to this lexicon, you will see that article sizes are extremely unbalanced. So major parts of this lexicon are copied from other places, and you will find articles that cover tens or even almost 100 pages, and you will find other pages where you have 20 or 30 small topics covered in very small descriptions. It's all accessible on the web. You will not have difficulties to find it. We received the images of some volumes from the Bavarian State Library. In our experiment, we started with scans from 14 pages of Zedler. Well, one remark here, one of our referees said it would be better to, if the persons would have used a random selection. Yes, in a way, I agree, but here a random selection would really lead to difficulties, and the reason is that Zedler is completely unbalanced. When we tried with a random collection, the selection of pages we received was really not adequate for doing the experiments. So we decided here for this preliminary experiment to really select 14 pages. We then prepared 3 versions. The first version was the OCRed version. We used FineReader. The second version was the ground truth, which we prepared manually. And the third version was ground truth, where we modernized orthography, but really only orthography. This is a point we shall come back later. Then we manually assigned topics to each of the pages, and we applied automated topic assignment for the 3 versions of each page. And we looked at recall and precision results obtained for the 3 versions: OCRed page, ground truth page, and ground truth with modernized orthography. And we analyzed the results and the problems. One word to the OCR quality of these texts. In our settings, the percentage of correctly recognized words, I mean here tokens, not types, is around 75% on average for the pages. It's a little bit worse for words of length longer than 3, which are more important for the purposes of information retrieval, etc. Here, the OCR accuracy on the level of words is only 71%. If you go one step further and compare the OCR output with the ground truth where the orthography is modernized, then we get worse results on average. Then the OCR recognition result corresponds to the modernized orthography of the correct word in 68%, and for words of length longer than 3, it's 62%. On this slide, you find some examples, but just for illustration purposes, of manually assigned topics. On average, we assigned 25 topics per page, and you see here the topics for 3 example pages. One page only has one main lemma, or so one concept which is described on this page, and it's Zeugen, which means witnesses. And you see the topics we have here: contracts and handicapped persons, children, etc., corruption. The second example is another page. It's a page which covers several lemmata and describes several concepts, and yes, you see that the range of topics is really quite large, and from topics we would expect to those topics we would perhaps not always expect. This is just meant for illustration, and in the full version of the paper you will find all the topics extracted. Now, here are the results we obtained for recall for the automated extraction of topics. What we asked is which percentage of the manually assigned topics were really found among the computed topics. And here I need to explain this picture. Let's start with a diagram on the right-hand side. This describes the situation when we do not impose any restriction on the significance value given by topic sum. So if we collect all topics which were in the topic sum output, regardless of their significance value. The yellow bars refer to the modernized ground truth, which you can consider as the optimal form of text. And here we find something like 50% of the manually assigned topics. The red bars refer to the ground truth, which is also an idealized form of text. And you see here it's a little bit lower. The recall is around 40%. And the blue bars refer to the text we really have. This is the OCRed text, and there it's something like 35% recall. If you impose stronger restrictions on the significance value, then of course you will get a smaller collection of topics found in the output, and it depends how sharp this line is drawn. For example, if you select a significance value of 0.6, which is kind of reasonable significance value in many experiments, then you see that the recall for the optimal text version is something like 30%, and for the other versions of the text, it's something like 25%. By the way, you might perhaps ask if here's an indication that our results cannot be true. If you take the sharpest line for the threshold, you see that the recall is larger for the OCRed text than for the ground truth text. And you might think this is impossible, but it's impossible. This goes back to a technical point, that this significance value is a kind of, for those of you who know what this means, a kind of TF-EDF value. And in this TF-EDF schemes, you do not only count the number of occurrences, but you count this and compare with occurrences of other topics. So I will not go into details here. You might have the feeling that this recall is low, but look at this example and you will see that the notion of recall we used here is not really fully adequate. Assume that you have assigned spatial areas on a map, and what an expert does is he finds 5 areas, a big one and 4 important sub-areas which he marks on the map. And then comes the computer and he marks all the same big area and 4 other areas which are really closely related to the areas found by the expert. Then in this situation, the recall is just 20%, since the only region which was found exactly is the large region. And the recall value does not take into account the similarity of all the other objects that were found. This points to a difficulty which we have in finding appropriate evaluations here. And in fact, in one page, for example, manual extracted topics were children and teenagers, and they were missed, but we found childhood and adolescence as topics in the automated output, which did not contribute to the recall here. So this means that intuitively the felt recall, which we cannot compute, is larger than the computed recall. But of course we also have real problems for recall. One is of course very rare topics. In the Sedler you find topics you will not find in our net. And the most interesting point is where is what I call the changing word. In this Siedler lexicon, you find topics from part of the world that have dramatically changed. Old professions, old habits, old techniques. And if you find description of paper production, of hunting, of perfume manufacture, and for example also potency means, that's a good example. If you look in a modern text for potency means, you would look for Viagra. But in the 18th century, there was no Viagra yet. And of course, old professions, etc. So this is really the most interesting part, the most interesting source for problems. Now, to precision values, first have a look to the inner circle here. This refers to the OCRed text, and the green part of the whole cake refers to correctly recognized topics. The yellow part of the cake refers to questionable topics where we did not have a conclusive answer, and the red part refers to wrong topics. And if you go from the OCR, where we have something like 20–25% of wrong topics, the percentage goes down when we go to ground truth texts and to ground truth texts with modernized orthography. Here we selected a significance value of 0.6. In the paper you will find more details for all 14 pages. And again, what were the main problems here? Well, as to OCR, the OCR had problems to recognize years, and this led to many wrong time periods which were assigned. A more prominent problem was the wrong resolution of ambiguous words. Many words in the text were confused with the names of small villages we have in our modern hierarchy, and in this way we introduced several wrong topics. And the special problem again were language changes beyond the pure level of orthography. So I just take one example here. The word Flüsse, which means rivers, was used in these pages for liquids of the nose and of the eyes, which is completely strange in modern text. And this led to several wrong topics, rivers and more general geographic objects, which were assigned by our automated methods. As a resume, one point I would really like to keep you in mind is we have here an unavoidable, well, we can discuss this, an unavoidable subjectivity of evaluation. It starts with manually assigning topics to these pages. If you would take two experts that assign topics to these pages, they would not end up with the same result, since topics are really fine-graded. And if we then later classify computed topics into correct or questionable or wrong topics, then again, two persons would not completely agree on this. We do not have any good way to deal with this. My recommendation would be, whenever you read a comparable investigation, do not primarily believe in numbers, try to get your own impression. So recall and precision values can be very misleading if you do not know what has been measured exactly. Okay. So, one point of a resume, we really think that automated topic assignment is valuable and useful if errors are considered acceptable, and insufficient or non-appropriate if you think that errors cannot be tolerated. That is, if you want the lesson learned. Future work, we will try to extend the empirical basis. We try to realize improvements and combine with social tagging, and you look at the new versions I mentioned before. Thanks for your attention.
Do you intend maybe in the future to combine it with sentiment analysis? So you have articles which are pro a topic and against a topic?
Yes, this would be definitely a very interesting thing to do. I would extend this perspective. So the question was if we plan to extend this also with a kind of sentiment analysis. This is in fact an interesting thing to do. Topics is not the only interesting metadata we could use here. Sentiment analysis, which tries or more general emotional analysis. Sentiment analysis is basically, is it positive, is it negative? Emotional analysis is more going into details. Is it angry? Is it, I don't know. It tries to find emotions hidden in the text. This would be a very interesting additional approach, and what would be also very interesting to combine it, of course, with some kind of genre classification. We do not have genre here, and if you look at historical documents, genre detection would also be very interesting.
I have a... But I have a very loud voice. Okay, now it works. Klaus, thank you. Very interesting. Now, my question relates to the use of this, of the topic Zoom. Is it in any form now to be, has it been used by digital humanities researchers, or is it in any form to be used already?
It is used by many workers in humanities, but they are mainly coming from Munich University. And well, it's not used in a commercial way, but they just use the free interface, and yes, it's used.
It's used, and what kind of results do they get from it? Can you give an example of the sort of research?
Well, results is always really difficult, but I can give you a recent application of this. One problem people have tried to solve this with this kind of technology is person disambiguation. You know that there are many person names which do not belong to one person just, but to several actual existing persons.
Yes.
And of course, it's a huge problem if you want to find references to norm data. You find a person name in the text, but you do not know which of this person XY it is.
And they've applied it for this.
And here you can use this technology for disambiguation. You should just look for the topics which are mentioned in the text, and the topics the person is known for, and then you can try to disambiguate with this technique. So this is one typical application.
Okay, so it's been applied, and it's available for German and English, I understand.
Yes, and the version for German is more powerful.
And what about exotic little languages like Dutch?
We are interested to do this, but it's a matter of person month to do it.
Okay, thanks.
Yeah.
Thank you. I was curious about your semantic network, and I wonder whether that is partly based on WordNet data. And if it is, would it be possible to use older dictionaries to adjust the semantic network to older meanings of the concepts?
Well, to answer the first part of the questions, it's not based on WordNet at all. In fact, one motivation to create this own net was that we looked at WordNet and found that WordNet is strongly motivated by more or less purely linguistic considerations. And if you look at multi-word expressions, you will not find too much in WordNet. If you look for persons, for organization names, for events, for centuries, for geographic places, then WordNet is not really good. And this was our motivation really to introduce our own net. So WordNet is not used here at all. What was the second question again? Sorry.
I see the point of WordNet very well. As the first WordNet, at least, was based on a dictionary, I wonder whether an analysis of historical dictionaries could be used to detect previous meanings of concepts and expressions.
I mean, if you would like to refine this net for really for historical text, the first point I would do is to introduce new orthographic variants, since we are aware of typical patterns which describe the difference between modern and old orthography in German. For example, the difference between K and C. and we have other patterns of this. So it would not be difficult to extend the lexical basis of the net. A much more complicated thing would be to avoid ambiguous notion or to try to deal with the problem of ambiguous notions. This was really a problem also here. Historical orthography lead to ambiguities we never have seen before. So one error which occurred here very often, to give you a concrete example, there's a very often used German word which is bei. It just means at. And in this historical orthography, it was written with not with an I at the end, but with a Y at the end. And B-E-Y is a title for a Turkish nobleman. And our net got completely confused by this mentionings of by with Y and thought this text has something to do with Turkish noblemen. And this is the kind of errors you really only find when you move to concrete texts. So one idea behind this net is do not have the idea to create a net and that's it. Each net needs a life cycle. You have to use the net, go to text, see how it works, repair it, improve it, take out notions which are too ambitious, introduce new notions you have not found, etc.
There's still time for one question. Is there another question there? Well, if you need one. No, I don't need it. I have one. I have a similar question. I have one. But if you have one else, I think you go ahead.
Yes, I was wondering about, let's say, this false friend problem. If you have a large collection like this one, could unsupervised techniques like LVA help you find these false friends? Because you can see that, for instance, this flutes or this by will get assigned a topic which is completely unsimilar to the one which would get assigned by your procedure.
Well, false friend detection, from my point of view, the point in all results concerning false friend detection is the question, do you know the suspicious words? If you know the suspicious words and just have to decide if it's really a criminal or if it's okay, then the job is not too hard and you can use all kinds of disambiguation methods. But the real problem in practice is to find the suspicious people in these words, to find text parts where you think, well, this could be a false friend. And this is much more complicated, and I do not have a good answer here.
Well, we can talk about it.
By the way, you can use the net in the proceedings to find pointers to the web pages, and if you're interested, just go there and put in your text. Even no registration is needed. Thank you.